I'd say whenever you're ready, Andy.
All right,
We can get
okay.
started.
Okay, folks, let us begin the Nantucket Conservation Commission meeting for Monday, May 22nd. We are recording this, and if you are recording as well, could you please let us know? Very good, Steve, Bryce. If you have your cell phones, could you please put them on silence? It'd be appreciated.
Real quickly, too, sorry to interrupt. During the public comment session, either at the front for non-agenda items and during the public comment session of the discussion, if you're going to speak, please come to the microphone and identify yourself. We are recording this so we can get it up on the town website so other people can watch, and for all of us to go home and enjoy again later. And we get general comments to the town for all meetings that people do a really terrible job of speaking into the microphone. There are 2 there that are available, so please try your best to use those. And you do have to get kind of on top of them to get picked up really clearly, but please do so your comments can be heard on the recording.
Very good. Okay, so we are going to start with the public meeting, public comment. If there are items that anyone would like to make comment on things not being heard tonight, specifically the SBPF, and would like to talk? Nobody? Okay. So now we're going to the meeting for doing the annual report of the Sconset Beach Preservation Fund. This is just the annual report. This is not for taking any action. This is just to hear the report from SBPF, so just to let everyone know that.
Right, so if there are any questions or comments, this is kind of fact gathering, but any change in any permit or requirements or discussion of that would require an actual hearing to make changes to the permit. Again, this is to ask questions and hear the report, and then at the end, if the commission wants to take further action or feels a need to take further action, we'd have to post it and advertise it for the appropriate hearing type for a later agenda.
Okay. Very good. Couldn't have said it better. So we're going to start with SBPF making their presentation.
I'm Maria Hartnett from Epsilon Associates for SBPF, and I'll be taking you through a slideshow that I made for our annual report. And for any of the commissioners, as you know, the annual report was comprehensive, so in the slideshow I have attempted to condense things, but I'm happy to stop at any point and go into more detail if you have specific questions. So Jeff, if you want to take it to the next one. I pulled together a quick outline just to let you know how we'll be going through the report. I'll be starting with the monitoring results. That's where we will be spending the bulk of our time. There's a lot to discuss there, from sand delivery, bluff monitoring, shoreline, beach invertebrate, underwater video, etc. And as I take you through each of those monitoring components, I'll be presenting our findings, and then I'll also be including the comments from the third-party reviewer, Greg Berman. And as I've indicated there on the screen, I've outlined his comments in green so that you can easily keep track of what his comments are. The annual report also includes recommended changes to the monitoring and mitigation program. As has been announced, we aren't asking for any of those changes tonight. We understand a separate filing for an amendment would be required, but we are starting to discuss some of those recommendations. Then we have a response to the comment letter that was received from the Land Council and Applied Coastal. And then we'll just talk you really quickly. We were going to tell you about the sand delivery that we just finished. So that's the outline for tonight. Next slide, please. So the key findings, and these are similar to when we came in August and provided you with an interim update. These key findings are similar. So as a reminder, the geotube system has been in place now for almost 3.5 years. We've made it through about 4 winters. So we have quite a bit of data to review. So far, the geotubes have held up well. The base of the bluff has been stabilized. As we look at the shoreline data, we're seeing that the position of the shoreline is within the range of where we would expect it to be based on the historic data. We're not seeing any indication of adverse effects from the shoreline data. Likewise, when we look at the bluff data, we're seeing that our mitigation template is contributing more than the unprotected bluff. And overall, as we also look at things like the beach invertebrate, the wetland well, or the underwater video monitoring, we are not seeing any indication of adverse effects. Next slide. I'll start quickly with the sand delivery report. That was at the start of our annual report where we provided delivery tickets and documentation that all of the required sand had been delivered. And that's really the take-home point, is that it has all been delivered. And at the end of the sand year, which was at the time of this annual report, it was at the end of March of 2016, we had about 3,000 cubic yards surplus. And I added in the note there that we said a surplus from a previous year was countable if we indeed delivered that surplus and it remained in the template at the start of the next year. Next slide, please. Now I'll take you through some of the comments we received on the sand delivery report. The first one is there was a comment asking about why we counted some of the bluff erosion sand as mitigation. And so I wrote back that I think a little bit of a clarification would help with that comment. The sand report the last few years has been very complicated. I'm sure you've all enjoyed reading it, but we have been trying to track both the sand for mitigation, the sand for the construction, the sand we placed on the bluff face before we vegetated. And what we tried to make clear in that report is that any sand placed on the bluff face was not counted as mitigation if it stayed on the bluff face. But when we were constructing the fourth tier, we had to uncover that third tier, and a lot of that sand slumped down and became available. And so we were saying that sand did indeed count as part of the mitigation. And likewise, the bluff face was continuing to erode. There was some erosion of the bluff face before we vegetated it. And since the mitigation sand is trying to mitigate what the bluff would have eroded, we felt it was appropriate to count what the bluff did indeed erode as part of the mitigation. And so I think with some of that clarification, again, we're saying only sand that is available to the system is being counted as mitigation. So I hope that serves to clear that up. The last comment from the reviewer was that we didn't have the most recent sand delivery data. And again, the annual report was prepared in December before that data were available. So we just completed that sand delivery, and we'll be submitting another report within the next month or two. Next slide, thank you. I'll start on our monitoring with the aerial bluff survey. This was done in April of 2016. And we intend to do this annually. The second one for this year was just completed. We'll be happy to present those results to you later. We used a UAV to capture imagery and elevation data. It was a photogrammetry survey. We then geo-referenced everything. And again, we intend to perform this annually. For this first survey, the most recent survey we had to compare it to was from July of 2013. So on these next few slides, you'll see us comparing the 2016 data to the 2013 data. Next slide, please. I included this image so you could see the type of information we were able to develop from the survey. We produced a digital elevation model from the survey, and then we also made a 3D model of the bluff face. And we were able to get a lot of useful information from this, and I can take you through it on the next slide. So on this slide, we were able to look at how the bluff changed both above the geotubes and in areas to the north and to the south. We were designating a north control area and a south control area. In the north, we had about 800 feet where the bluff was unprotected, so we could see how this natural unprotected bluff performed. To the south, as you might be familiar with, there are quite a few jute or core terraces out there. We didn't want to use any of those as a control area, so we have a smaller area. It's about 200 feet where it's unprotected. And using the survey data, we could work out how the volume of the bluff in each of these areas had changed. And what we were able to determine was that in the unprotected areas, we distance weighted them. It comes out that they contributed 12.9 cubic yards per linear foot per year. And we can use that number as a check on our mitigation volume of 22 cubic yards per linear foot per year. Next slide. We were also able to work out how much sand was left in the template. So in April of last year, at the end of the winter, we still had about 14,000 cubic yards in the template. That's about 14.8 cubic yards per linear foot. As required by the order of conditions, we also calculated where that sand fell. There was a request in the order of conditions to figure out how much was above the fourth tier. We did calculate that as about 2,200 to 2,300 cubic yards. But we note that, as you've probably seen, this template is continually changing. Anytime we need to recover the tubes, we're taking sand from the top and pushing it down. So that sand that is currently considered unavailable is getting pushed down over time and is then becoming available to the system. Next slide. So this slide is meant to be a quick summary of what we found. In the geotube area, we've confirmed that all mitigation sand has been delivered, the 22 cubic yards per linear feet per year. Of what has been delivered, as we just saw on the previous slide, a lot of that volume was still sitting out there. So 18.1 cubic yards per linear foot per year have been contributed. We know about that much has washed away. And again, about 14.8 cubic yards per linear foot per year were remaining in the template as of April 2016. In comparison, the unprotected bluff areas over the last 3 years were contributing about 12.9 cubic yards per linear foot per year. So this is one of the many tools we used as we're evaluating the data, but based on the bluff monitoring, we are seeing that the more mitigation sand is being contributed than the unprotected bluff. Next slide, please. Now I'll move into some of the third-party reviewer comments on the bluff survey. He was asking for some additional information or metadata on some of the technical specs of the survey. I think that's a very reasonable question to ask. So we prepared a response to comments document. I included all of that information there. I picked out a few here. So I've showed the horizontal and vertical accuracy, all between 5 and 8 centimeters. I provided information on the number of ground control points we used, the grid cell resolution, etc. So that information is now in the record. Also, the third-party reviewer pointed out that there is some additional LiDAR data, and we are aware of that, and we appreciate his noting that. And I also added a note back that when we originally calculated the bluff contribution volume, we did do several checks on it. We used data back to 1994. We did some shoreline data checks, and we did some survey data checks. So I think he was recommending we do some checks of that, and he didn't have the complete record. Obviously, it's quite voluminous by now, but some of those checks he was recommending, we did initially check it with both bluff survey data and shoreline change data. So now I'll move on to the shoreline monitoring data. We have some updated plots to show you. As you know, the shoreline monitoring is done quarterly at 46 transects. The monitoring area is about 6 miles long. You can see all the profiles there shown in yellow and red. During shoreline monitoring, the surveyors measure both the change in the position of the shoreline, which at this site is the mean low water line, as well as the change in the volume. And then twice a year we do bathymetry. That goes from -5 mean low water out to -25 to 35 mean low water, which is often 2,000 or 3,000 feet offshore. And the bathymetry is done in the spring and fall. Next slide. Now I'll be taking you through some of the shoreline monitoring trends. I reviewed the possibility of including all 46 slides, but thought that perhaps we'd go with a representative subset here. And so what the next few slides focus on are, we picked one slide to the south, 84, that's at Codfish Park. Then we picked the profiles that were closest to the geotubes. So we have some that are 500 and 1,000 feet south. We have 2 profiles that are within the geotube area. And then we have 3 profiles immediately to the north, within 1,000 feet to the north. And then we also picked 1 profile to the north, near the north end, and that's profile S. So I have 9 slides of shoreline change plots. And for some of these, I'll explain it here. We don't have a pointer today, but I'll have to come up and point to the screen, and then I'll come back to the microphone if that's okay. So a lot of text here, but let me hit the high points, and then we'll move on to the plots. What we find when we look at the historic trends is that there's an overall trend of erosion. The shoreline bounces up and down, but the overall trend is erosion. We also found a high degree of natural variability, and I'll show you that on the next few slides. We'll see that from survey to survey, the shoreline can change 20 feet, 40 feet, etc. So there's quite a bit of variability. We also found that each profile responds differently. Sometimes we have one profile accreting and the one next to it is eroding. And so we found it was best to look at each profile, compare it to itself, because there is quite a bit of difference from profile to profile. We also found that given the variability, we have times where the shoreline changes dramatically for a year or 18 months. So for the geotubes, we'd be looking for a sustained trend out of the ordinary for about 2 years so that we could really attribute it to the project. Most importantly, we found that the current shoreline, which again, our annual report was submitted in December, so at that time we had data through October. For tonight's meeting, I went ahead and updated those so that I could share with you the most recent data, which is from February 2017. So what we're finding is that our current shoreline position is within a position we have seen in the historic record. It's similar to where the shoreline was about 8 to 10 years ago. So we aren't seeing anything that we haven't seen before. And overall, the post-geotube shoreline changes are not material different from our previous observations. So we're not seeing changes that we haven't seen before. Okay, so let me take you through this first shoreline plot. I'm going to take you through these. I have 9 of them. I wanted to start with those plots that are in the geotube area. Then I'm going to move south, and then I'm going to move north. So right now we're going to start at profile 91. This is one of the profiles that is right within the geotube area. On our x-axis, we have time. So the first point is from 1994, and then as we move to the right along the x-axis, we're moving to present day. The y-axis is shoreline change, with higher numbers towards the top. And so as you move towards the top, we can think of that as accretion, and lower numbers. The downward trend is erosion, the upward trend is accretion. The last thing I'll explain is that the blue points are all the pre-geotube data points, and then the red points are all the post-geotube data points. So a couple of features I want to point out, which were mentioned on the previous slide, is that there is quite a bit of natural variability. I'm going to move forward to point something out really quickly. All right, I've got to get my jump shot out. Okay, so if we go right here, do you see that high point? That's 40 feet taller than where it was before. Likewise, we get points that up here, it drops 20 feet and goes back up. I don't want to stay away from the microphone too long, so go back. But what we see on that plot is, yes, there is clearly an overall trend of erosion, but there is definitely short-term variability of 20 feet or 40 feet. And what I see on this plot is that right before the geotubes went in, we had that considerable bluff erosion. That significant erosional event led to the shoreline to build out. And that's what we've seen through time. The bluff erodes like crazy, the shoreline builds out, and then quickly erodes and comes back to normal. And so what we're seeing here is that the shoreline is continuing to erode, but overall its position, if you scoot your eyes over to the left 8 or 10 years ago, you'll see that the shoreline is within a position that we had seen about 8 or 10 years ago. And so what we would be looking for is, do we see the shoreline in a more erosive position than we had seen before? I'm going to point one more time. We have our overall trend right here. Thank you. If we were seeing points down here, we would be really worried, or we would be concerned that the mitigation sand was not keeping up. But we have our points above where the trend line would fit. So we're not seeing anything that's indicating accelerated erosion. Maybe I'll use the mouse. That was a good idea. Okay, so moving to the next slide. Thank you. I appreciate it. Okay, so the next one, 91.5, this is also in the geotube area. And again, we see an overall trend of erosion with quite a bit of variability. There's the mouse. You can kind of pick out the erosion trend. So don't look at this, look at that. Okay.
Maria, I'm a little confused. Ms. Ernie, I'm a little confused at what these slides mean. Is this a comparative position, or is this how much it's changed that year? Like, does each one of those dots indicate a specific change in a year, or is it relative to where it was?
It is a change in a year.
Okay, so it's the further toward the bottom of the slide means it's changed a lot in that year.
No. I'm sorry, please tell me your question again.
So if you look at, say, the very last point, does that mean it's, about 70 feet less or so, or it's eroded about 70 feet since 94, or does that mean it eroded 70 feet that year?
No, since 94. I'm sorry, I
Okay,
didn't
so
understand
it's
your
not
question.
really the change, it's actually change or shoreline position compared
To
to.
90.
Okay.
Yes. Thank you. So this one again. Yes, thank you. Appreciate it. So what we see again, the overall trend of erosion. We see things, again, each of these lines here is about 20 feet. So at times, from survey to survey, the shoreline might change by about 20 feet over time. But we can pick out the overall trend is about here. This changes in that winter of severe erosion. You can see the shoreline jumped outward from the bluff. I believe it's often hard to say for certain, but this seems to reflect the bluff erosion contribution, and then things are slowly moving back to the original trend line. So that's what we are seeing there. And again, what we would be concerned about is if our overall trend is about here, and we're getting consistent values down here, we would feel that could potentially signify an adverse effect.
Where's the point? Where's the 1994 point?
just off the screen. In order to make the scale fit, it's right over here at 0. And we truncated the plots a little bit so that we could fit everything in without throwing it off.
So 1994 is at 0.
Yes. That's our baseline. That's when the survey started, so 94 is at 0. Now we've looked at the 2 plots in the geotube area. We're now going to move south. So this is profile 90.6. It is 600 feet south of the geotube. Again, we have an overall trend of erosion, but 90.6 is one of those extremely variable plots. Again, you'll see within a short time frame of a year or two, the shoreline grew by 60 feet and then nearly vertically eroded quite quickly and then went back to more of a stable position. So at 90.6, we have historically seen a lot of variability. We do seem to be picking up on the same trend of the shoreline building out right after the tubes went in. After the tubes went in, the shoreline is eroding and it's moving back to being more consistent with where the trend is. What I think we're seeing is in the record, we've had times where the shoreline built out and then nearly vertically corrected itself. So right here, we are seeing the shoreline is eroding, but it's at a little bit more gradual than right here in the previous record where we had the shoreline building out. So because of that, again here, we aren't seeing an indication of an adverse effect. With the overall trend being around here, we'd be looking for a cluster of points down here to indicate that there's potentially an issue. Profile 90, this is 1,200 feet south of the geotubes. Again, the overall trend of erosion, a series of outlier points where there was more severe erosion over 60 feet, but then it corrected itself and went to the trend. We again see the beach building out due to the bluff erosion, and most likely due to the bluff erosion, and then the shoreline starting to correct itself and going back to more of the trend. So again, in this location, we do see the shoreline moving back to following the trend, but overall it's in a position here where it was about 8 or 10 years ago. So we aren't seeing anything we haven't seen before. We aren't seeing anything that indicates an adverse effect.
Maria, I have a question for you. Did you actually fit trend lines to these?
Yes, so this is something we have wrestled with. Do we use a trend line or not? We fit trend lines to every one. Our R-squared values were between 0.5 and 0.7, most of them. We had one that was like a 0.88. And so we were wrestling with, do we want to show them, do we not? For those profiles where you're getting down to, an R-squared of 0.5, that means most of the time your data really aren't falling on that line. I had to go back to my college stats. I think it was, 25% of the time it's a good explanation of the data. So we wrestled with that and ultimately decided to show the scatter plots you see today.
Thank you.
So this is the last profile I have to the south, and then we'll move to the north. This is profile 84 at Codfish Park. It's 1.3 miles to the south. And I should also preface this by saying we would expect any impacts from the project to show up right next door first. And then if we aren't seeing them there, then we would expect farther away they wouldn't just show up on their own. So we are really focusing on those profiles in the immediate area of the geotubes. But we also wanted to check some to the north and the south just to see what we were seeing. Well, at Codfish Park, I'm sure many of you are familiar with this, the beach had significantly eroded. It built out considerably, and since then it's been slowly eroding. But since the geotubes went in, there's been a gradual accretion. Now, we'd love to take credit for that, but it's 1.3 miles away, and so I have to believe this is most likely natural variability. All right, now we're jumping to the north. So now we're at profile 92. This is 100 feet north of the geotubes. As with the other profiles, we're seeing that overall trend of erosion. we're seeing the natural variability where at times the shoreline can go up by 20 or 40 feet, other times we're more erosive. And again, right before the geotubes went in, the beach had built out a little bit, and it is continuing to erode, but at about the rate we would expect, similar to how it was performing before the geotubes went in. So again, here we're not seeing an adverse effect. At profile 92.5, this one is more flat. So we're seeing overall trend of erosion again, but it's at you can probably see the slope is much shallower, and that's similar to what happened after the tubes went in. We've had some erosion and some accretion, but overall what we're seeing here isn't really that different than the historic record or the historic trend. So we've got a couple more plots to the north. Now we're at profile 93, which is 1,100 feet north of the tubes. Again, this one is more stable, less of an erosional profile. We're seeing the values bounce around a little bit within 20 or 30 feet, and likewise we're seeing a pretty similar trend after the geotubes went in. The last one we checked was profile S. This is 2.7 miles north of the geotubes. This profile also has a lot of natural variability. At times the shoreline is changing by 10, 20, 25 feet or so, or even here close to 30. What we're finding is that there was overall accretion, but right around this point, it's starting to switch into more of an erosional trend. We are seeing more of an erosional trend after the tubes went in, but it looks like things were starting to change a few months before the geotubes went in. So with our not seeing any adverse effects closer, and with this point being 2.7 miles away, we aren't seeing anything that would attribute this change to the geotubes. It does seem to be part of that natural change.
So, question on this graph, are we actually eroding or are we just not accreting as much? Because this looks like a positive change.
So what we're seeing here is it does seem like an overall trend of accretion through here, and then it was just starting to either erode or stay a little more stable. And what we're seeing is just some seasonal variability, but it is, to me, looks like a little bit of erosion. Starting, I think each of these were 6 months apart, so starting a couple of years before the geotubes went in.
Maria, how do you define shoreline position? Is it mean high water?
It's mean low water.
Mean low water. Okay.
Yep. It's mean low water. Thank you. One other thing on the beach topography. So this was something, I believe back in August at the interim update, we were asked to provide a map of the topo in addition to the shoreline change plots to have some additional data to look at. So this was done for the annual report. So this was October of 2016. We have contours from 0 to 15, mean low water. The beach is from roughly 0 to 10. The toe of the bluff is about elevation 10. So if we're just looking at the colors, the blues and greens are pretty similar. Here's the geotubes, so you can pick them out. The blues and greens, which are about from 0 to 10, those are looking pretty similar along the stretch of beach. When we start getting into the yellows, oranges, those are more tightly spaced in front of the geotubes. Those are from 10 to 15. So right here, they're picking up the steep slope of the geotubes. So kind of as expected, those contours are more spread out to the north. And then as we get to the mitigation template that's more steep, they are more tightly spaced, and then they spread out again to the south, and then they're more tightly spaced again in front of the Jute and Core terraces. So what we're seeing here is that overall, from 0 to 10, the beach looks pretty similar in front of the geotubes and the areas to the north and the south. And then those contours from 10 to 15 are a little more tightly spaced, but that's due to the steep face of the template. Now I'll take you through the response to comments, those comments from the third-party reviewer. So Ernie, this goes actually just right along with your comment. One thing that Greg Berman asked was whether we wanted to use the mean high water line. And so as I note there, we agree that if you're doing remote sensing, if you're doing photogrammetry or LiDAR, you do want to use mean high water to make sure your mean low water isn't being obscured by waves, et cetera. But here at Sconset, we do have the actual survey data down to mean low water, so our mean low water line is accurate. It's a surveyed line. Also, the mean low water datum is the established vertical datum for the project going back to 1994. That benchmark was tidally established, so that mean low water value is very well known. Also, Greg's comment was that you might want to know where the mean high water line is. That could be closer to the infrastructure. But the beach at Sconset is fairly steep, so it's usually just a few paces from mean high to mean low. And overall, we have this over 20-year data set with data reference to mean low water. And so we would hate to lose the ability to compare to those previous 70 surveys. So we do feel that sticking with mean low water is the most useful way to utilize the data we have. And again, this top comment was also asking about using mean high water and whether we should utilize that. And again, we noted that every survey has been measuring mean low water, and based on the 70 survey record, we do feel that mean low water is sufficient. And his last comment is he did agree with us on our interpretation of the shoreline data. He indicated that the major changes in this dynamic area completely overshadow any signal that might be from the GeoTube project. No additional shoreline change can be attributed to the project at this time. So that was helpful to us to have him confirm that the way we're seeing the data, he's also coming to a similar conclusion. All right. The shoreline monitoring was the longest one, so thanks for hanging in there with me through that. Now I'll move on to wetland well monitoring. So as you know, there are the system of wetlands out on Baxter Road. We've got our catch basin at 91. We put in 3 wetland wells, E4, E2, and E6 right here. Those were monitored as required by the order of conditions in June, July, and September. What we found was that the water levels went up by 1 or 2 feet. They seem to correlate pretty well with precipitation data. When we got a lot of rain during a particular month, I would see that the values were higher. Overall, we're not seeing any evidence of harm from the catch basin. That's consistent with what we are expecting. The catch basin is across the road from the wetland, and so we aren't expecting it to adversely impact the wetland. Looking at the peer review comments, he agreed with us, saying that it's highly likely that the catch basin has no effect on wetland water levels on the west side of the road. Then to his next question, he was asking for more information on the 50 previous well readings that I referred to in the report. I guess we didn't give him 10 years of data, 1 ton of papers. So I pulled out those old records. For those of you that were on the commission, you might remember that wells were previously required to be installed, and they were monitored from 2001 to 2007. So it's been about 10 to 15 years since any data were read from those wells. So the most we can say now with the passage of time is that previously the historic well low readings were about 7 to 8 feet. What we found now were about 8.5 to 10 feet. So the water levels are a little lower now, but again, there's no indication that's from the catch basin. I think it's just that things have changed in the 10 to 15 years since we initially collected that data. Okay, now I'll move on to the beach invertebrate monitoring. In August of last year, we conducted the required beach invertebrate monitoring. We picked 12 grab samples. The sampling locations were specified in the order of conditions, so you might remember we had to do 3 north of Hoyks Hollow, 3 north of the project area, 3 within the project area, and then 3 to the south of the project area. Overall, we did not find much. We found across all 12 locations, we found 8 species. Other than the mole crab and beach flea, for everything else we just found 1. So overall, very low abundance, very low diversity. What we found in the project area was not different than anything we found in the other areas. The species number or richness within the project area was 1 to 3. In the control areas, it ranged from 0 to 4. And essentially, if I had to give a 1-sentence summary of what we found, it was mole crabs. So consistent at all locations, we found mole crabs, and that was the dominant finding. This next slide goes into a little more detail of what we found. Overall, the low density and the low diversity of the fauna, it's not surprising given the environment and the coarse-grained sediments. Mole crabs really are the main thing we were expecting to find. Based on what we found, there's no evidence of harm to the invertebrates in the project area. Also, there's no resource species where we sampled. We didn't find anything really unique or special. Though the authors of that study indicated that they did not feel additional monitoring was warranted, given that there was low diversity, low abundance, and no real noteworthy species. Next slide. Going on to the peer review, his comment was consistent with our conclusion. He stated that the low abundance of the invertebrates in the area likely do not warrant further sampling. Okay, now I'll move on to underwater video monitoring. We've conducted 2 surveys since we received the order of conditions. Here in green, these are the geotextile tubes, just so you can orient yourself. We collected underwater video along shore parallel transects out to about just under 2,000 feet offshore, and then we also did some shore perpendicular transects. We looked at all the video while we were taking it, but in order to generate some maps, we picked these intersection points where we grabbed still screenshots, and then we used those to map the percent cobble or boulder on the bottom. Next slide, please. So this map shows the percent cobble and boulder as interpolated between the different survey points. This was from our first survey in June of 2016. We use color families to help guide your eye as you're looking at this. So our green color families are less than about 25% cobble, and that's just what we would expect to find, lower cobble onshore and generally higher cobble offshore. The blue colors are about 25 to up to 70% cobble, and then we put in red those that had greater than 70% cobble. Overall, what we found is that offshore Sconset, there is a great cobble habitat area. It continues to be there. It's directly offshore. We found a number of fish and invertebrate species. We found, again, this widespread cobble of around 25 to 50 to 70%. And we didn't find any indication that it was being covered or destroyed by the sand template. Now I'll go into the response to the peer review comments. In our annual report, we went back and looked at the best available data we had. These were from beach nourishment days and were from 2007. And in our report, we stated several caveats. We used this data because they were the best available, but 9 years had passed, and so we knew these were not exactly the ideal pre-construction set of data. And that's Greg's comment as well, is that the dates were too far apart. So I would say we agree with him totally. I think the general conclusion we can draw, though, is in 2007, again, we're seeing mainly those blue colors, the 25 up to 75% cobble. We're seeing a nice, healthy habitat. And in 2016, we're seeing the same thing. So again, no evidence that it is being covered. Next slide. A little bit more here on the response to comments. So the peer reviewer noted that there are several different ways you could survey this area. There are other options like side scan sonar. Side scan sonar gives you seamless coverage, so it would give you a map of the complete area, but you would then lose information on the flora and fauna. With underwater video, you see exactly what's there. And so he was throwing out some additional ideas. On the side scan sonar, we said, we are happy to look into that. Again, any type of survey has positives and negatives, and so that's something we'd be happy to discuss with the commission. The way we see it, again, side scan sonar gives more seamless coverage, but it is an indirect method. With video, you're actually seeing what is down there. And we do some video ground truthing, but we get a lot of information on the video as well. He also recommended a couple of other techniques, sediment profile imagery, where you stick a little probe down into the sediments and you can see what's there. That one, we really don't think that's going to work well in the coarse grained sediments and cobbles. Also, you would need to be able to visually distinguish the nourishment sand from the native sand. Here, it's compatible sand, so I don't think we could make a meaningful visual distinction. And so on the sediment profile imagery, we don't really think that one would be that helpful. But again, we're willing to take a look at side scan sonar. It's just up for discussion in terms of what provides the best data. Every source has advantages and disadvantages. The underwater video has been great in terms of helping us capture all the flora and fauna. We could get more seamless coverage with the side scan. I also wanted to present our October 26th underwater video monitoring report. This report came out right after the annual review was submitted, so I just wanted to pull a couple of screenshots so that you could see the type of information we're looking at when we make these maps. There are hours and hours of this available, so if anybody is highly desirous, we can make these files available, but I will give you the 30-second edition. So I picked some screenshots. These TR numbers are the transects. So these all start at near shore, and then as we move across, they're farther offshore. So closer to shore, no surprise, more sand. As we move offshore, we begin to start picking up both flat sand and the cobbles and the boulders. The way we analyze these data is we put the grid on, and then for each of the 9 squares, we assess how much was sand, pebble, cobble, and then we took an average so we could get a composite for all 9 frames. A lot of shells out there, and then again, these last 3 show that there's a very productive habitat out there with boulder and cobble in the 30s, 40s, and 50%. One thing I want to mention using a slide like this is that we found that where you take your screen grab really matters. On this slide here, we're coming up with boulder 30%. If we went back half a second, we might get more of those boulders right in the middle, and that would give us maybe boulder 60%. And so as we were interpreting results, we found that we needed to be a little bit careful in terms of if we see it originally was boulder 60% and now it's boulder 40%, well, then we would go back and look at the video. Okay, are we seeing that things are actually covered, or is it just if you move your screen grab, your percent boulder or pebble, your percent boulder or cobble will change a little. So I will insert that caveat into this when looking at results. Really quickly, I'll mention the biota. Again, we looked at those through time. As we compared June and October, we were seeing the same dominant species of the brown and red algae, the breadcrumb sponge, and the rock crab. The difference between June and October in terms of some of the species, like we didn't see as many spider crabs, but they bury into the sediments. Some of the fish species had moved offshore. So overall, the differences we saw seemed to be based on natural movement of the species, and overall we saw this great, beautiful habitat area and no indication of an adverse effect. Next slide. This screen shows bottom coverage of cobble and boulder, looking at June over here and October over here. Overall, we do see some similarities. So again, we have our lower percent cobble closer to shore in both maps. And as we look at both maps on the whole, we see that overall we're in those blue colors, the 25 to 50 to 70%. Any place we saw a change, like 0.11, it went from a red to a blue. Again, we take a look at the video, check and see is something being covered. And we really didn't see that. It was more simply our screenshot location. It's going to be different. Each transect is going to be a few feet off each time. And so we did check any point where there was a significant change like that. So overall, in both surveys, again, we saw this very productive cobble habitat area offshore. We also weren't expecting significant changes from June to October in terms of cobble boulder coverage. There was only one storm that occurred, and so the amount of sand removed from the template was pretty small. Overall, what we found is the volume of the sand template is minimal compared to natural sand and shoal movements. I did a quick calculation, and if we lost our entire sand template at once, if it all moved right offshore, it would cover the area out. I used a distance of about 1,500 feet offshore. That's the depth of closure. It would cover that area by 4 inches. When we go back and look at our bathymetry records, we've seen changes of feet or more. So we do feel that the sand template volume is small compared to the natural changes we see out here. Moving on to annual drainage system report. Again, we checked the catch basin at 91 Baxter Road. Overall, the system appears to be functioning as designed. We noted there were 4 inches of sediment in it. This was last fall, below the threshold of cleaning. And we indicated we'd be happy to monitor the system for another year and then turn it back over to the town like the other catch basins. The peer reviewer said the same thing. He said the system is likely performing as designed. Okay, now we've made it through all of the monitoring data. In the annual report, we do have some recommended changes to monitoring now that we have had a complete data set to review. Again, these are recommended changes for discussion. No changes are being proposed tonight. We understand an amendment would be required. So the first one is we believe that the bluff monitoring should occur annually. We were able to get a lot of good information out of that. Right now, the order conditions just says we have to compare the top of bluff annually. It doesn't specify the bluff monitoring, but that's something that we intend, the aerial bluff monitoring, we intend to do that annually. On the shoreline surveys, we do want to make some adjustments there to collect the most meaningful data. So we want to include plots of shoreline trends, like the ones I just showed you. Woods Hole Group had started doing that. Previously, we just had the table. We felt that adding the plots made the data a little more accessible and easier to review. So those will be in all the shoreline reports moving forward. We have a recommendation that the shoreline frequency can be changed to twice a year. The peer reviewer agreed with that and noted that that's consistent with Mass DEP. So far, we do have 10 surveys that have been done since 2014, so we have collected quite a bit of data. The next point is on the bathymetry. The recommended change is to change that from twice a year to once per year. And part of the reason is as we are trying to look at the most useful data, we do feel that watching the shoreline position provides us a good indication of any potential adverse effects. When we move out to the bathymetry, we feel like this is most useful for understanding regional coastal processes and if shoals are moving through the area, but they aren't conclusive for determining the impact from the geotubes. And for that reason, we would suggest we focus on the shoreline monitoring and reducing the bathymetry to once a year, and also consider reducing it to 22 profiles, which is about half of them. So run bathymetry on every other one, and that will allow us to continue understanding regional coastal processes. The last one is on wading shots. As we've been looking at survey efficiency, wading shots are done from 0 to -5, and these capture a small portion of the overall volume in the profile, but it does require a rodman out there swimming. There is a safety risk inherent with having someone out there. We've also found that it doubles the length of the survey to get this last little bit of data. And so Woods Hole Group performed an analysis that's included in the annual report of simply extrapolating from 0 to -5, so continuing the land-based portion of the survey out to 0 mean low water, but then for that last little bit, simply extrapolating based on the slope. And what they found is the error was about 1.1 cubic yards per linear foot, which is a 1.4% difference. So it was a very small difference. So Woods Hole Group had a lot of confidence that extrapolating could still get us high quality data. The third-party reviewer did have some comments on the recommendation to eliminate the wading shots. He was suggesting that wading shots can be important if you've got a sand berm right off there, a sandbar right offshore that you want to pick up. And so we noted here, we're not sure if he got to see the profiles at Sconset, but we don't typically have a sandbar offshore. It's a pretty steep beach out to -7 to -10. And so wading shots don't record sandbars and the associated volume here. Greg also had a good suggestion of maybe you just walk it out to -2 to -3 and then extrapolate the rest. Unfortunately, while we wish we could do that, having done 70 of these surveys, the surveyors have found that 0 mean low water is really as far out as they can go before they need the swimmer. And overall, the error of extrapolation was about 1.4%. And that error of 1.4%, again, that's based on the volume of 0 to -5 mean low water. And we do think that 1.4% error is correct. Greg had asked if it was going to go up to 8%, but we were explaining that it's the volume between 0 and -5, so that 1.4% is correct. All right, next slide, please. Also on the beach invertebrate monitoring, now that we have done the monitoring and have seen what is out there, and it's pretty straightforward, mole crabs, nothing different in the project area than elsewhere, we do feel that that can be discontinued, and the third-party reviewer agreed with us on that. Likewise, on the wetland wells, we've gone out there, we've seen the wetland is doing well, our results were correlating with precipitation, we didn't really see anything. We felt that could be discontinued, and the peer reviewer agreed with us on that. On the underwater video monitoring, we were suggesting we bump that frequency way down. Again, based on the fact that the mitigation volume is really minimal compared to natural conditions, we were suggesting we could bump that down to once every 3 years. Or if something crazy happens and the template is just contributing so much more sand than we would expect, then that might be a good time to check. And overall, the third-party reviewer agreed with us on that one as well. On the drainage system, we propose to continue to monitor it for one more year, and then we suggested that the DPW can monitor it like they do with the other catch basins. And the third-party reviewer said if the town is willing to do that, then that should probably be fine, be minimal effort. Next, I want to move on to recommended changes to mitigation. So as you all know, the current mitigation volume is 22 cubic yards per linear foot annually. We calculated the bluff contribution volume back in 2013 as 14.3. So the 22 cubic yards does have an element of conservatism in it. When Greg was reviewing this mitigation volume, he included the statement that the standard calculation is you take erosion rate by height by length. And so I ran through that exercise. We had done it before. When you run through that exercise, you actually get 12. And there's a reason why we decided to be a little more conservative in the future. Or, excuse me, we were a little more conservative back in 2013 when we calculated this. We actually took profiles of the bluff. If you do length times width times height, you're just taking a quick vertical slice through. The bluff is at an angle and that whole face erodes. So we were more careful than just taking a quick vertical slice. That's how we got the 14.3. So we were already more conservative than what the standard practice is. Because we are finding that we do have a lot of sand still out there on the template, again in April of 2016, we had it was 14.8 cubic yards per linear foot per year still sitting out there. We were recommending a more adaptive mitigation program. We had two potential ideas for review and discussion. First was just set the minimum at 14.3, so make sure that much is set out each year, and then if more than that gets taken, continually cover the geotubes throughout the year so that no maximum is set, but it would be based on what is actually being taken instead of a blanket 22 cubic yards that gets set out no matter what. Another idea that DEP actually suggested that might also be a good adaptive means is DEP said that at the end of each year, check to see where you're at. Whatever is in the template at the end of the year can count as a credit towards that 22. So you would keep the 22 as the requirement, but if the natural system doesn't take it all, then a credit can be applied towards the next year. I thought that was an approach that still allowed some conservatism to occur in the mitigation volume, but then also allowed a little more adaptability for those years when erosion is lighter. These are the peer review comments on the mitigation. He was wanting to make sure that no matter what, we keep the geotubes covered, and I think we're completely on board with that. We do try to get them covered within several days. As soon as the storm activity has quieted down, we go out and recover them. He was also saying we could reduce the safety factor over time. That's something that can be considered, and again, though the project has been in place now for 3.5 years. Overall, we are recommending a more adaptive monitoring approach to more closely mimic natural conditions with less sand in lighter years and more sand in more energetic years. Next slide. Okay, now I have just about 3 slides to respond to the comments from the Land Council and Applied Coastal. There were questions about long-term and short-term trends. There was a plot included of water levels and how short-term trends can differ from long-term trends. And we agree that we want to focus on the long-term trends. And so looking at the shoreline change data, I believe Applied Coastal was concerned that in some cases we are seeing erosion since the geotubes were installed. But as we looked at those shoreline plots, we saw that in all cases in the natural system, there were also times when the erosion was fairly steep. And so we want to keep focusing on that long-term trend. And as we look at that, the shoreline is within the expected position. So we had our notes there. We found those similar short-term shoreline changes over the long-term record. Next slide, please. This comment brings up, I think this is a valid point, on the bluff monitoring. It's a question about what we used as control points, and it's asking whether the areas to the north and the south that we use as control areas, if they had lower or similar volumes to the bluff in front of the geotubes. So I went back and I calculated the bluff erosion rates for the geotextile tube area, the north control area, and the south control area. I used the exact same methodology that we used to originally calculate the bluff contribution volume. This does indicate that the north and south control areas did contribute a little less. It was about 80% of the volume from the geotextile tube area. And so I said we can add a note to our reports that the control areas may slightly underestimate the volume of sand that would have eroded from the geotextile tube area. However, I do want to add a caveat that there is a lot of spatial and temporal variability in the amount of bluff erosion. For example, when I ran through this, the reason why it was 80% was driven a lot by 3 transects on one lot. The southern 3 transects on lot 87, those really got hammered in 2013. So those are showing huge losses. If I took those out, it was 90%. So we're kind of getting within the range of error. So overall, again, it's similar, 80 to 90%, but we will add a note that this might be a little bit, the control areas may erode a little bit less than the geotube area. Overall, it doesn't change our conclusion, though. We still have the mitigation template is contributing more than the unprotected bluff. The unprotected bluff was 12.9. If we add in that 80%, if we account for that, it goes up to 16. Again, that 80% might actually be 90%, so then it would be 14 or 15. So somewhere in there is the unprotected bluff, and our mitigation sand is at 18, so still a healthy margin greater. And then I just added a note that overall, as we look at the project, we're looking at the bluff data, the shoreline data, and the historic bluff data as well. So we use all of those together, not just one piece of data to look for adverse effect. Okay, this next comment is related to what we are using as our mitigation volume, how the 14.3 should be higher. I will go over this briefly. I know this has been the subject of many hearings back in 2013. I included our table from 2013 where we looked at past projects. For the current project, it's 14.3. For some of the past projects, it was 12 here, 12 there, and 7 there. I think some of the confusion is that some of those earlier projects included a nearshore component of about 7 cubic yards per linear foot, and that was the volume of sand out to -26, which is about 1,500 feet offshore. So that's why there's a discrepancy. Some of those older projects included sand out to 1,500 feet offshore. The current calculation is focused on the bluff since that's the eroding landform. Next slide. The last couple of comments were an agreement on the aerial bluff monitoring, and so again, we do intend to continue that. There was also a comment about shoreline monitoring, how it could be shifted to twice a year. So we agree with that. The order of conditions does have it at 3 years. We are almost at those 3 years of monitoring. They didn't agree with us on the weighting shots, and again, we do feel that this The errors are small, 1.4%, and the survey efficiency is huge. It cuts the survey time in half. So we continue to recommend that. Last, there was a question on reducing the number of survey profiles. And again, I just wanted to clarify that that recommendation was for bathymetry only. We aren't suggesting changing any of the profiles for the topo surveys that allow us to track the position of the shoreline. And for bathymetry, we are simply suggesting essentially do every other one. And again, the reason for that is that the offshore profile is generally stable, and so the bathymetry once a year is sufficient to characterize that regional morphology. We aren't proposing any changes to the shoreline position data because we feel that those are the most useful for evaluating the geotextile tubes. Next slide, please. We made it. So last slide on the conclusions. Again, the tubes have stabilized the base of the bluff. The surveys have shown the project has contributing 18.1 with the 22 available. The unprotected bluff has contributed 12.9. Again, we can adjust that up a little bit, call it 14, 15. In April 2016, you can see in this photograph here, there was still a lot of sand sitting out there. It simply hadn't all been taken. Overall, the shoreline monitoring data shows no indication of accelerated erosion within or directly adjacent to the tubes. And likewise, looking at the wetland wells, the beach invertebrate monitoring, and the underwater video monitoring, we aren't seeing indication of harm to the invertebrates or of cobble habitat being covered.
Maria,
Yes.
another question. The unprotected bluff contributed about 13 foot per year. Is that in the recent, what time frame does that represent?
Okay, so this was from the annual report. And so that survey was done in April 2016. The most recent data we had to compare it to was from July of 2013, that LIDAR data. So we were looking at the most recent 3-year period, at the same period as when the tubes went in, as
Okay.
close as we could get. We just completed another survey this year. Those data are being processed. So what we're hoping is that every year we can do this so that we can see what's our mitigation sand doing this year, what's the unprotected bluff doing this year. We can see how that compares to the 14.3 historic rate. We can just make sure that the mitigation sand is keeping up with the historic rate and keeping up with what the unprotected bluff is doing. The last thing I'll point out is this slide, it does show the sand delivery that just occurred. So the template was just refilled up to 22 cubic yards. So we will be submitting another sand report within the next month or two after we get that aerial bluff survey data processed. The survey just occurred yesterday.
I had a question about the the slopes. The comparison, you were comparing slopes of the area above the tubes and the banks to the north and south. I mean, and I know that the review had brought up the issue that the southern the southern bank is also has protection, so it's a tough one to use as a comparison. But the northern bank, I mean, the northern bank to me, when you're talking about a low slope and you have a bank of accretion and an erosion rate of 14 cubic yards per linear foot, it seems to me that's more of a stable bank situation as the ones above the tubes in the north. I mean, in the center and to the south. And we've had the situation where these banks get really steep, and then you get failure on the banks, especially the ones to the south. So in a fun, interesting way, I think to kind of set yourself up for failure potential with the steeper the banks go. I'm not sure if it's necessarily, I mean, yes, the erosion rate is less because you have a tube on the bottom, but I'm not sure if you're in the best situation because of it. It's just my observation.
So you're saying that the historic, what we were trying to say is that we were comparing the historic erosion rates where the tubes were to the other sides to make sure we could use them as comparisons.
Yeah, I guess one of the things that's hard for me to see is there was no data on the top of bank And I mean, and if is the, and I'd be interested to see what the erosion rate of the top of the bank is, especially the north, if we have a shallower slope, but we also have an accreted beach. So I'd like to see the whole picture. It seems to me we're not quite seeing the whole picture in this report.
Yeah, we can add that, and we did.
Yeah.
And it's for that reason that we didn't just want to look at the top, because you're right. Sometimes the top is steep, sometimes the top collapses. So that's why we were looking at it from the toe to the top, because we wanted to capture the complete volume.
Mm-hmm.
But we could, going forward, we could add a figure that shows the top of the bluff.
The
from
retreat
year
at the
to
top
year.
would be interesting to me. I think it would be kind of tell the whole picture of what's going on there as well, or help to anyways.
Yeah, I think that's something we could definitely add in.
Okay. So I guess we'll open up to questions from the, we're going to start with the commission members first. So do we have other questions from the commission?
Sure.
Any questions? I guess I did have another question. Actually, okay. No questions from the...
Not right now.
Okay, I know I have some in the notes, but I will... Jeff, you have a comment? Okay. I will open it up then to the public. And if you could please come down to the microphones with your questions and identify yourself, that would be appreciated. Do we have any comments from the public? Go ahead. Emily?
Thank you, Mr. Chairman. Emily Molden for the Nantucket Land Council. Thanks for the presentation, Maria. I think that the commission and maybe the public online have seen or received a copy of the comment letter that we submitted a few weeks ago. And I guess I would say primarily we were concerned about the request, or not request, the recommendation to eliminate or reduce a number of the monitoring requirements from the order of conditions. And I understand now that there's not a formal request before you to do so, but we do believe that it would be inappropriate to do so before the 3-year life of the permit is up. I think that while 1 year of data is important and valuable to see, especially for some of the things we've never looked at before, like the invertebrates, that it would be really important to continue all of that monitoring. I think one of the things that we're most concerned about is the recommendation to change and reduce the amount of nourishment for mitigation. And included with our comment letter were some more technical comments and concerns from our consultants at Applied Coastal Research and Engineering. And Trey Ruthven is here from the Cape to address some of those. So I'll just let him go ahead and speak to some of those more technical concerns. And please, after he is finished, ask questions as much as you like as well while he's here. Thank you.
Thank you. I am Trey Ruthven from Applied Coastal Research and Engineering. I just wanted to clarify a few points. Maria did a great presentation here. But the one thing that I think is sort of missing is, we have this long-term trend or long-term data set looking at shoreline profiles. And initially they had looked at, whether erosion was increasing or decreasing after this project went in. And just doing a quick analysis of the data pre and post, and granted the post is a short time period, but erosion rates have increased over all the transects they evaluated, which is a concern when we start talking about reducing mitigation volumes. And when we can talk about that, the period after construction as being short, the initial time window that Epsilon suggested using was a 2-year window, and we're beyond that 2-year window now of looking at erosion. So, considering erosion over a 2-year period, yes, it might change, but it's a concern. We are having an impact. We can start looking at bulk volumes. Obviously, we have the area to the south, which I feel between the GeoTube project and then Mr. Weimer's Jute project, there's a lot of material being placed in there to mitigate for the erosion that's going on. So it makes it very difficult to discern what's going on. I think if we start looking to the north, it starts actually providing more useful trends, since we only have the GeoTube project to the south. The interesting thing looking there is that, all of a sudden if we take out the southern one, our rate goes up, and then if we consider that the geotube project is actually located in the highest erosion rate, that's why it was placed there, that we're expecting it to be a bit higher in that area. So when we're mitigating for that area, we're trying to replicate that. And so let's talk about reducing volumes and what that means over time. So initially it came up with 22 cubic yards. There's a lot of discussion that goes into that number. But let's consider why it's out there, and that's the important part. We put this mitigation volume out because we're expecting on an annual basis this volume to be contributed. But we all know storms change. Some years we have a few, some years we have major storms. And so that volume that's contributed every year is not consistent. It goes up and it goes down. On the years that it's down, we're not contributing as much. The system has a chance to respond. And if we actually put a project in place that kind of stops that response, what we're doing is actually storing volume for those years when we have major storms. Because with the geotube project in place, that bluff can no longer give up sediment. So our neighbors to the north and south that are outside the geotube project, if we start reducing that volume, that during those big storm events that we have, the volume of sand will not be available to mitigate for the area that is protected. That means they're going to see increased erosion rates. And we all know once you've lost the bluff, there is no recreating it. I mean, we've spent years working on this, and to what success. So I think we need to consider when we're looking at that mitigation volume, because that's really what it is, it's mitigating for having this project in place, it's the neighbors to the north and south that we must consider. Because once we lose that bluff in front of theirs properties, there's no putting it back. We can have a long discussion about what that appropriate volume is, but obviously last time it was not arrived at as just a 1.5. I mean, there was a lot of discussion involved, which I'm sure some of you are new, but some of you probably do remember the discussions that went into that. And it was based on, scientific analysis, engineering analysis that all went into this. So it's hard to say, bluff erosion rates are very low, hence our mitigation volume should be low. At the same time, we're requesting putting these big structures in place because our bluff is eroding quickly. So we have to consider that. I mean, really right before the project was in place, which is, I wouldn't consider it normal. I mean, we were losing, somewhere up of 70 feet per year on the bluff. I mean, it was outrageous, but that's a single year, and that's what we were seeing in that plot is those spikes up and down. But we need to keep that average going because otherwise it won't be appropriate. The mitigation changes, or not mitigation, but the monitoring changes overall, obviously the board can consider that. Some of them had some merit, some of them less so. I think the critical point moving forward with any changes in monitoring is to consider where is your long-term data. You don't want to lose any stations that have long-term data. If there's a transect that got put in over some of these smaller projects that have gone on that does not have a long-term data point, that might be a good candidate to consider. But the long-term data sets that are there, we do not want to jeopardize moving forward. They're critical. I mean, they're a valuable resource to the town. They're a valuable resource to SPBF. So make sure when you're considering any changes to that you consider where the value is in that. And whether it's an hour or two lost in the field doing that, that's not really critical versus the whole time period that we're talking about and the extent of this project. But be careful as you make these changes or consider these changes of what's happening, what's going on, and how this will affect the natural system. Thank you.
Thank you very much.
If I may, Andy, sort of piggybacking on what Troy just said, it seems to me, and this is just anecdotal, I tend to watch the weather, especially during storm events, to see what kind of winds are coming, where they're coming from. And it just seems to me that most of our storms now are coming out of the northwest and not out of the northeast. And given that, it seems like especially our sustained high winds are more nor'westers now instead of nor'easters. And I think just sitting on the commission and seeing that our main requests for armory now are like in the harbor, and I know people down in the Nantucket area that are like kind of going nuts because they're afraid they're going to lose the bridge out to Smith's Point and the road is eroding and stuff. So I just wonder if we're seeing a weather change that may account for the relatively low bank losses on the East Coast. And I think that would be helpful to see some kind of summary of wind over this recent time period compared to the past. And I think it's really important to remember that this project was all came about because of not a rare year, but an unusual year of Sandy, and then I think we had 2 big storms banged right afterwards, and that's why we lost all that bluff. And everybody was like, 30 feet gone in 1 year, oh my God, you know. But I don't think we've seen anything close to that since. That doesn't mean next year we won't have it, of course, but
That's why we also, too, we thought there was maybe some merit to DEP's idea of keep it at 22, but allow there to be a credit. Just as the template gets higher and higher, we have had some quiet years, and we all understand that there will be energetic years. That's why we have consistently said we will cover the tubes as needed. So we aren't ever proposing a maximum, but we're trying to be a little more adaptive, so it isn't just that pile gets higher and higher and higher. Even this year, we just delivered some, and it's higher than it's ever been. So I think after we get the sand report in a couple of months, that might need to be something we discuss in terms of where do we put it all? Do we continue to put it all out at once?
So,
And how do we handle those years where it is a little quieter, when there is a safety margin incorporated into the mitigation volume?
when you say the sand template is higher than it ever has been, how many periods of time were the geotubes uncovered then throughout the storm season? Because I know that there were certain periods after storms that it was uncovered.
Yeah, they were typically uncovered for a few days after each storm until they could get covered. I don't know the exact number. I'm going to see if Josh or Jamie, 5?
and how often did that happen, Josh? Do you know? 5?
5 times.
That's the way it's designed.
Correct.
It's not a failure, that's the way the project is designed.
Hey, Josh,
Down in the front.
we're not picking you up at all. Could you use the microphone, please, and identify yourself?
Sorry, I didn't mean to jump in on this, but since I started, I guess. Yeah, there were 5 occasions, because I was just checking this out recently. I think it was September, and then maybe not till January, and then 2 in January, and don't hold me to this exactly. 2 in January, I remember, and I think 1 in March and 1 in April. And the way the system is designed is that the sand in front washes away, and sometimes it might just be one layer of tube for a portion of the length, and sometimes it'll be the whole length, and in a couple of cases it washed away 2 layers of geotubes. And then, in between, we send down machinery, Jamie's folks, and sometimes they can't get on the beach right away because the storm is still strong for a number of days. And they'll take a bulldozer and grade the top and push the sand back over the front so that it's recovered again.
What effect is the addition of sand on the tubes having on the beach grass that was planted on the bank to stabilize the bank? I would see a potential problem there of having to pile so much sand that you start burying that grass so deep that it doesn't survive.
Right. That is one item that we are considering, and I'm going to turn it over to Jamie because he just oversaw the sand delivery. So we had been trying to leave a little buffer. I'll turn it over to Jamie so that he can speak to that.
Hi, Jamie Feely for the record. So we're going to cover each time we do a major nourishment like this, a certain amount of the beach grass. And this year it may have been 5 or 6 feet of the beach grass that we covered along the bottom of the template. And I think the plan is to replant that as needed in the fall. So if we push down and expose 3 or 4 feet or 5 or 6 feet of the bottom of the face of the bluff, as the template gets reduced in size, we'll obviously take that opportunity. It's either, it's either that, or inversely, if we're do another nourishment in the fall, for example, and we're going to reintroduce another 4 feet, which would be the case this year, that may not be required. But I think it's in our best interest to certainly keep that whole situation stable. So we don't want to see any sloughing, because the bottom is now not very stable due to vegetation. And then I just commented, Josh pointed out that we did 5 pushes or covering events this year. I think in each event it was when the entirety of the tube was exposed, or certainly the majority, and there's been many smaller scenarios where we've gone out and just covered up, you know, a 20 or 30 or 40 foot scenario.
I have a curiosity question. You say you lost 18 cubic yards a linear foot last year, or I'd say lost,
on average,
but contributed.
Yes.
Contributed. How many cubic yards are needed to cover the tubes as well as on the tails, on the ends?
Oh, just to cover the tubes and the
No,
ramps?
yeah, what kind of volume is needed? I mean, say you've lost 18, but then again, how much is in the covering aspect as well? So that would kind of bring up your number, because obviously you have to have that to cover your tubes as well.
Sure.
So I would say probably on average about 1.5 yards, but somewhere between 1 and 2 yards. And I think
Okay.
it depends on, you know,
Right.
what's happened to the face of that template relative to that particular blow.
Right.
Is it just, you know, uncovering the face of that second tier,
Mhm.
or is it taken more? And so generally when you push it over, it gets to a consistent angle of repose for the template.
Right. So basically you're at 20 cubic yards you've used for the project for this year.
Well,
Well, I mean, you have 2 that's still there, but basically you have to have that coverage. That's what my point is.
well, I'll let
I'm
Maria.
not sure. I'm sorry, I'm not sure I understand your
Well,
question.
you're saying you lost 18.
Yep,
Okay.
18 were contributed.
Was contributed into the system. But then you also have to, you put 2 yards into covering the tubes as well, and which have to be covered at all times. So basically you've contributed, you've used up 20 requirement. If you hadn't used those 2 yards and you said 18, you'd have exposed bags. Do you understand the kind of my point?
I don't think so, because we have so much out there, and so we just keep pushing it down and pushing it down. And so what has been pushed down and eroded during storms is the 18.
I understand. Okay. Maybe I'm not.
So it hasn't, so can I just clarify? So
Sure,
the
sorry.
18 has been pushed down, but some of that could still be sitting in front of
No,
those
the
tubes at this
18
moment?
is what we know is gone.
gone.
It's
Let me
totally
explain
gone.
how we calculated it, and maybe that will clarify. So what we did from our delivery tickets, we know that we've put in the 22 cubic yards per linear foot per year for the last 3 years. Then we measured how much sand was in the template, that 14,000 cubic yards. When we do the difference, we know how much we put out, we know how much is left, so how much is gone? How much is gone was the 18.1. So what's sitting there, including the amount required to cover the tubes, was the 14,000. But what is no longer there, it's not in the ramps, it's not in the template, we can calculate that pretty straightforwardly, and that was the 18.1. So I hope that helps clarify. It doesn't.
No,
I did
it
my
does.
best.
It does. I understand.
So-
Pre-existing is what you're saying, basically, and what you replaced.
So essentially this year you have 4 yards per cubic, per linear foot extra, if you've only contributed 18.
That's, yes.
Can I go back to the 5 times the tubes were uncovered?
Sure.
Is there any way to quantify how much sand would have been lost if it were available? Because I know those time periods usually are still very stormy. That's why you can't get equipment there, but that's also when you'd really need that sand. I know it's difficult.
It is challenging. That's why we try to do it once a year. That's really the best way to quantify that is with that aerial survey. And so we do plan on checking that on an annual basis. Otherwise, when we go out, there is that post-storm report. We do look at the bluff to the north and the south to see, has it taken a beating? Can we visually tell? But obviously, it's visual, very qualitative, very limited.
Thank you.
Okay. Other questions? I think we.
Good afternoon, Mr. Chairman and Commissioners. My name is Rick Atherton, and I'm here today on behalf of the Nantucket Coastal Conservancy. Usually, Deanne Atherton would be here. She had a knee replacement surgery on Tuesday and is not as mobile as she would be otherwise, so I am here in her stead. We've submitted a letter, and there are copies for everybody. An electronic version was delivered. I might make highlight, I think there are 4 items in the comment letter, and they're really a different focus than the sort of highly technical and computational and sand delivery system. There are many other requirements in the order of conditions that I think we might, on an annual basis, take a look at as well. First of all, there's been a lot of discussion about erosion, and as I heard the consultant say today, erosion is continuing on a normal basis, not that it's been accelerated or decelerated in any way attributable to the geotubes, but I think we all need to be concerned about the language we use, whether we're the proponent or people who have a different perspective when we talk about the erosion. And I'll just give you one quote. There's a document delivered to the board that it says, once installed, referring to the geotubes, erosion has been stopped. And it goes on to say, and there is no evidence of harm to the neighboring shorefront areas. Certainly that last part of that statement seemed to be corroborated by the statements you've received, but erosion is continuing on a normal basis. So I think we all just need to be careful about the language we use to describe the project. The second item in the letter to refer to, an important issue for the Coastal Conservancy is a walkable beach. That's a requirement of your order of conditions. There's been no comment today about how wide that walkable beach is, how many days during the year it's available for walking, how many high tides go right up against the geotubes and intrude on the walkable beach. And I think the Commission would be interested in knowing, or I would hope they would be, on how walkable it is during the course of the year. Another comment, one of your conditions, condition number 44, reads that the town of Nantucket is an assenting property owner and SBPF as the applicant shall provide the Commission with updates every 6 months on the status of efforts to relocate alternative access and public utilities infrastructure at the northern end of Baxter Road. Now, such a report has been filed with the Commission. I don't happen to be aware of that, and I think it's important that when you have a condition that it's followed up and the parties who are requested to make such a report do so. One other area I think you need to pay attention to as you go forward and really as you get into the request which is coming to you within the next year, the failure criteria for the project. And some of these are quite specific. One of the failure criteria includes H, failure to meet reporting requirements or good faith effort to provide reporting requirements. And I just read that because the one I just mentioned about a report from the town and SBPF every 6 months, frankly, should not be that difficult to provide. And I think you might want to take steps to ensure that it's provided to you. Okay? So the copies of our letter are there, and I thank you for your attention.
Thanks for your comments, Rick. I'd like to just say a few things about each of the 4 points. And we absolutely wish Deanne a speedy recovery. Those knee replacements can be challenging, but the results are fantastic. It's amazing what science is able to do to the natural deterioration of the knees. The first comment was that I wrote a letter that said, since the installation of the geotubes, erosion has been stopped. That's true. The toe of the erosion, the toe of the bluff, erosion at the toe of the bluff in front of the geotubes has been stopped. Clearly, erosion where the geotubes are not installed has not been stopped. That continues, and that's what Maria has been monitoring in terms of whether we can see any evidence of erosion accelerating or changing that might be a result of the project. So, point taken, but we're just speaking about the exact project. Erosion has been stopped there. The walkable beach is something that we pay a lot of close attention to. I think we're doing pretty well with the walkable beach. Obviously, during a big storm where waves are running up far enough to wash away sand from the front of the geotubes is not a time when you can walk in front of the geotubes. But in general, certainly for the entire summer, I don't think there was 10 minutes where you couldn't walk in front of that beach. And most of the time there's many yards. The question about regular updates on alternative access, we've been dealing with the town on that. We are right up to speed with that and have accomplished all the things that were intended. There is now in place an alternative access agreement with all the parties that are affected. It's been that way for quite a while. I know this point that Rick is raising was raised 4 or 5 months ago, I think. And the reporting, I think, is from the town. But in any event, we filed a letter with the commission giving everybody an update on the alternative access, which I think gets 100% credit for being accomplished. I don't think there's any more reporting that's required. It was asked for at a time when the alternative access agreement was not yet in place, but that was, generally agreed to in principle. It's now fully documented and in place and signed off by the Board of Selectmen, as well as the Golf Club, Wisconsin Trust, and SBPF. So I don't think there's any issue there. And then as far as these failure criteria, we are doing, I think, a bang-up job of monitoring this project. I doubt that there is any project anywhere in Massachusetts that has the kind of monitoring and order of conditions requirement that we have. The quality of monitoring that we're doing, I think, is outstanding. And so we're taking it very seriously, and we hope that it contributes to a good, rational discussion and a positive exchange of ideas and data-based analysis on the project, and something that hopefully supports what we're doing and maybe helps the whole island learn something about erosion.
Stephen Cohen, I'm with counsel to SBPF. I read the Coastal Conservancy's letter, and I just want to respond sort of generally to two concepts that are in it, and we could respond in writing. But there's this concept of, hey, this was supposed to be a temporary emergency thing, and it should be on its way out once you reroute the road or something. And then there's also this concept that's been floated that all of this mitigation is important and none of it should get rolled back. And I think that both of those are somewhat mischaracterizing what we're doing here. And I think it's important to think of this and remember where we came from and where we're going, which is that the emergency aspect and the temporary aspect was for how we're going to deal with this, and that this project has always been viewed as a long-term project that would hopefully last a long time in its success in protecting this area of Wisconsin, but also be expanded. It was never supposed to be, a Band-Aid that was going to just be ripped off once, once the need for it evaporated. The need is never going to go away, and there was never a suggestion that it would. Baxter Road is not going to be rerouted in any way. The utilities are not going to be just moved, and the situation never solves in terms of not having a need to be addressed. So, but what I do think we have is a situation both in sort of the temporary and emergency aspect of the project and the temporary and emergency aspect of the mitigation was that this has never been done before on Nantucket or basically almost anywhere, and everything was done with an abundance of caution. And when we talk about making recommendations in this report of ways to look at changing it, we're looking at how to improve it and get the best data and the best bang for our buck in terms of mitigation and assessment. And I think that everybody went heavy on what we should look at and what should be done, with the idea of we'll look at that data and see what it provides us, and as we move forward and look at is there a better location to put the sand? Is there a better time to put the sand? Is there a better way to measure how we're doing it? A simple 22 yards per linear foot may not be the most effective mitigation. And I think what we're looking at is how do we have an effective project, not necessarily a cheaper project. And so I don't want anybody to come away with the idea of, oh, they're looking at doing less. I think what we're looking at is doing what's most effective. And so we'll be, coming forward with the commission for many conversations about what makes sense here to get the most data and the best kind of protection in an appropriate way. Because obviously, if you do too much, you could flood the cobble with sand. There's lots of negative impacts. Or we could just be frankly wasting people's time and money measuring beyond what makes sense to gather data on. So I think there's a lot of good data and a lot of good mitigation, and I think that as we go through, we will find sort of the right balance of what makes sense for the mitigation and what makes sense for the type and location of the protection. So I just think it's important to keep in mind where we came from, what we're doing, and where we're going. And then there's going to be more process involved in going through that. So I don't want anybody to misread this report as recommendations for immediate changes of rolling anything back. That is not the intent of it. Thank you.
Trey Ruthven from Applied Coastal again. I just wanted to sum up a few points after what I've heard. Ashley had a really good point of talking about when these bags are exposed. We heard last year that they were exposed 5 times for roughly a week. If we add that up, that's roughly a month of time that this was not providing mitigation. And the one thing to consider again is once erosion has occurred north and south, it's too late to mitigate. It's hard to make whole again. That's why it's mitigation. So as we talk about adaptive, I think when we look at adaptive, whether we're not talking about the volume, but maybe how to get that nourishment or that mitigation volume onto the beach continuously. Because losing that month of time where we're not providing mitigation, especially during the winter when we're having storms, it's detrimental to the entire environment. So if we talk about missing 4 cubic yards of material that wasn't provided over a month, that's easily made up. The other thing to consider as we talk about just bluff versus beach, which we had that discussion, is this geotube system is sitting on the beach. So whether we're mitigating just for the bluff, we have to consider that the beach component that it's covering up also should be mitigated for. And to kind of just wrap it up, as we start talking about reducing, monitoring again, is, as Josh just said, this project is ongoing. They're talking about possibly going longer in the future. So it's important as you look at reducing monitoring is to consider where that monitoring data might be very valuable moving forward, whether it's next year or the year after, as this project might expand to protect more of Baxter Road and Sconset. So keep that in mind as you consider reducing what you know. Thank you.
Thank you.
Maria Hartnett, just wanted to add a clarifying comment. I think it is valid to look at recovery, but just as a reminder, so where the sand template sits, you can see it here. So on a normal day, it's not contributing sand. So I think saying, however, during storms, it is contributing sand when the waves begin to reach it. So I don't think it's correct to say that for 5 weeks out of the year it's not contributing sand. I think it would be more appropriate to look at the fact that it contributes sand during storms, and so we would want to be focusing on making sure that it gets recovered quickly enough so that it's not uncovered during storms. And we do typically do that. It's typically covered before the next storm. Sometimes, if they are too close together, we may not be able to do that, but most of the time I think it's fair to say that we get it covered so that the next time something would want to take that sand, the sand is available. Do you want to add anything to that, Jamie? Characterizing that, Josh? Sure. And that goes back to that aerial bluff survey. As Josh was saying, there are times in smaller storms when we do, or not even a storm, but smaller events when, because the geotubes are more seaward, they will contribute. We have had plenty of times where the geotubes have lost sand, and when we've gone out and looked at the unprotected bluff, it hasn't. So we roll that all back into this annual survey when we can actually measure. And so for those, we can see that the mitigation sand is contributing more than the unprotected bluff.
So, question. Some of those times that the bluff on either side isn't contributing, but the geotubes are, that would also be sand that the beach under the geotubes would have naturally given had they not been sitting there. So the beach would have contributed, even though the water didn't make it to the bluff. So that's a little bit...
It could have,
funny.
but there's more in the template than what would have been there on the beach. Oh, I think Jamie wants to add to that.
So, just to speak to that point a little bit, Ashley, as the guy who's out there before and after almost every one of these events, you're right that in the storms, the beaches will often, so I would say like the average elevation of the beach in the wintertime is probably around 9 feet. In the summer it's 10, maybe it's 7 or 8, but it's, it's pretty consistent. It's lower in the winter than it is in the summer. And after the storm, the beaches drop a foot or two, sometimes more during the storm, and you can see indicators of that. But, within a day or two, it's completely covered up again to whatever that general average is for the winter, 8 or 9 feet. So I feel like, that's going to go away and come back. But what's lost from the bluff or from the template, that just kind of, goes away and doesn't necessarily reappear the next day. So,
Yeah.
My observation of
Also,
the beach elevation.
gravity just won't bring something back up a template the way it would move the beach up and down. You wouldn't get like 2 inches just on the face of a template building up.
I understand, I appreciate it. I'm just saying that the recovery of the beach is very quick, within like 24 to 48 hours, maximum in general.
Other questions? Any questions from the committee, commission? Oh.
If there aren't any more questions, I just want to thank the commission a lot. I think that this is a very complicated project. It's been going on for years. It's going to go on for many more. And, the science and legality and politics of it are all a lot to take in. We really appreciate you having this special meeting and, digesting this report in advance and thinking about it as you go. We will digest some more of these comments and probably have a follow-up filing to deal with any more technical issues, but I don't know that there's more, immediate action planned. But thank you.
I did have,
I just wanted to thank Maria for giving a
yeah.
clear, concise report and keeping to the main points and, making it so we're not here until God knows when. Thank you very much.
I think everybody appreciates that.
I did just sort of an off question about the 2007 photo survey that was done.
Yes.
And I understand it was 10 years is a long time to show a relationship, but is there something from that you use? I mean, it's interesting that, obviously one storm could clear all those cobbles in that test area, but is there something you get away from that you can take from that personally that you've noticed?
From the 2007
Yeah, from the change
data?
in the coverage of the cobbles.
I think what I took away was actually that there was that similarity. What I took away was comfort in finding that we had that great productive area in 2007, and we still have it now. We know from the topo, the topo changes. Over from the video, we know from June to October it changes, but we were still seeing those same rough percentages. So I overall thought that it was broadly consistent, that habitat is consistently there. So that's the main point I took away.
Okay. Yeah, I was glad that you guys looked back at those. There's a lot of effort put into that. And yeah. Okay, thank you. No more questions? Okay, seeing not. Is there any future and other information that we are looking for as a commission? No?
That hasn't already been discussed.
Yeah, that's what I discussed, or something else extra. Okay.
So there's no action you guys have to take. There's no proposal, and it's not a
Okay.
hearing for something. So you can simply accept this as the annual report, and then we can all go home.
Before we all get adjourned and everybody goes their separate way, are we going to do site visits or just skip them this
Nope,
week?
we're just going to pass on them this week. Put
Okay,
this in
great.
place of.
Yeah, great. Okay. Do we
Unless
have
you really want,
No, I
to
don't
really
think
rub
so.
it in after this.
It's supposed to be rainy tomorrow anyway, so.
Motion to accept the report.
Okay, do we have a second?
Second.
All those in favor? Any opposed? Very good. Thank you very much.
Thanks, guys.
Motion to adjourn?
So moved.
Second. Excellent. So moved.
All right, thank you, everybody.
Great, thank you, everybody.